So,
Amir, there's quite a lot of background noise on your microphone, or it sounds like it's on your microphone. Every time you speak, there's a sort of whoosh that comes up.
okay, I will put headphones on. Hopefully that will help. Is any better?
Less of everything. You've gone quieter, but
okay. That's not good. Sorry, I have 4 computers in front of me with fans on and everything, so that can be the fans making the noise. I will just distance myself a bit, and I will try to.
you're okay. You're okay for me now.
Wonderful, wonderful. That's good. So again, hello. My name is Amir. I'm a research fellow at the University of Aberdeen. My background is electronic engineering. So I've completed my bachelor's, my master's, and my PhD in electronic engineering. So I would like to call myself a programmer because that's what I do all the time. But for my PhD and for my research, I've been applying machine learning techniques to a wide range of biomedical data. So it's from sensors to brain imaging and image analysis. And sorry, I would just try to log in on another computer so I can at least see what's happening here. So I will introduce the team. As you can see, the names here. There are 4 main people involved in this course and in organizing this course. And mainly we have Dr. Gordon Waiter, our Synapse image analysis group lead. And Gordon is the director of Aberdeen Biomedical Imaging Center, for those who don't know him. And he is a senior lecturer in the Division of Applied Medicine and an honorary clinical scientist in the NHS Grampian. His main area of interest is developing an aging brain, particularly autism and Alzheimer's disease for brain imaging. But he has done a wide range of other stuff, including face processing, cognitive neuroscience, self-processing, psychology, depression, and other things. He is one of the main people, not only in Scotland, but also in the UK, in terms of being an expert on the analysis of functional MRI data. And as I said, he has a large range of specialities, including like he has worked with a lot of people like physicists and radiologists and psychologists and psychiatrists and everyone. So Gordon is online and he's going to be helping me run the session and moderate the session. And he's going to help me a lot with the questions as we go forward, because he has a better knowledge and understanding of most stuff than me. I might not be the best person to ask some of the questions. We have Dr. Julia Horner and Dr. Martina Sciola. I don't know if Julia or Martina are here at the moment.
Yes, we're both in.
Hello.
Hello.
Hi.
Hello.
Good. It's reassuring to know that you are here. So Julia has studied mechatronics and microsystem engineering in Germany, and she has done a PhD in offshore wind energy from the University of Hull. And after a couple of postdoctoral positions at the University of Reading, Strathclyde University, she's now working at MathWorks as a deep learning academic liaison manager. and she's going to tell us what EMEA stands for, Julia.
EMEA is Europe and Middle East, Asia.
Wonderful.
So it's just the European region. So
yeah, I stole the line, so I didn't know what it means really. So.
no, that's fine. That's fine.
Good. And Martina has done a PhD on personalized medicine. She is a biomedical engineer in terms of her background for coronary artery disease. And she is now supporting academics with adopting MATLAB and Simulink for teaching and research. And she is a technical specialist engineer. And she has done research on a wide range of different engineering topics, biomedical, signal processing, and everything. So that's good. Did I miss anything, Martina?
No, that was perfect.
No.
Thank you.
Good. And I will move on to the course overview. So the aim of the course originally is to introduce you to MATLAB as a tool for technical computing and to give you familiarity with a large number of built-in functions, but mainly we're going to be focusing on image analysis problems, and I think that's what most people here are interested in. And we're going to help you with your data analysis and your visualization tools. And the structure is going to be similar to this, but obviously as we move forward, it's like subject to change. So that's why I had the survey, because I wanted to have an idea of what people are interested in and what they want to take out of these sessions. So we start with fundamentals and visualization. So these are mixed together. As we move forward, we do some visualization. And then we move to image processing, and we have machine learning and deep learning. Machine learning and deep learning are already reserved to be taught by our special topic experts. So Julia and Martina are going to take care of that. The way that I'm trying to design these sessions is that we are trying to have a practical session, even though we are not really in a practical format, but we do what we can do. And the first few sessions are for you to work through as instructors. As instructed. So I will talk to you about what we need to do, and then we get to several exercises, and then I will ask you to do those with me. And if you had any questions, please don't hesitate to ask and interrupt me. And I hope you enjoy the course. I'm expecting that by the end of this session, you have some knowledge about MATLAB generally, and you are able to do some arithmetic stuff. And hopefully we will manage to plot some stuff as if time allows us. And I'm expecting to sort of go through 200 built-in functions and tools with you, but we will see how many we manage to do. And by the end of the session, you can, in theory, write your own code and a script. So if you remember, there was an email that I sent around on Friday. So we are a small group. Sorry, it was a bit delayed, but I'm happy that most of you completed the survey. So before the session, I haven't checked, but right before the session, there were 18 responses, actually. It might be more now. But on my slides, I have 16 people who have completed the survey. You can see a range of universities and centers that we have attendees from. And we have a wide range of different positions. So we have postgraduate researchers, PhD candidates, clinical researchers and scientists. We have a few senior postdocs and research fellows. And one professor, Professor Peter Hancock. It's lovely to have you on board. And it's a bit embarrassing for me to be here teaching. We have a lot to learn from you. And I've heard a lot personally about you from my wife, Jennifer, who is doing face perception. And some of the attendees from University of Stirling didn't have and do not hold a MATLAB license. So I sent an email around a workaround of what we can do and what we can offer. So if you have any issues, let me know and I will try to help with that as well. So as you can see, the majority of attendees have specified that they are sort of amateurish in terms of programming level, and we are like expecting a lot of stuff. So I just highlighted some of them. So image processing, artificial intelligence, machine learning, and deep learning in image analysis. Sorry, my son is having a nervous breakdown. And some people wanted just general programming knowledge, and some people wanted visualization. So we are trying to address all of these, but I have to let you know that this first session is going to be mainly fundamentals. So as I said, I don't see who is at the moment attending the meeting. If you feel like you don't need to be in the session, I can't see you, just leave now. You have better things to do. It's going to be very basic. So I'm specified that we want to target this session to people who have no background of programming whatsoever. So if you feel like you don't need this, just leave now. And I will send emails around for upcoming sessions and what they are about, and you can choose which ones you want to attend and just come along. So why MATLAB? So MATLAB is a very powerful tool for engineers and for programming and computing. So it was originally designed by a professor in computer science department at the University of New Mexico, Professor Muller. And the name stands for Matrix Laboratory, reflecting its original purpose, basically, as a state-of-the-art software for matrix computation. And it was developed by Professor Muller in the 70s. And now it is developed and managed by MathWorks. So you can use MATLAB like a calculator and do like very basic stuff, which we are going to start doing. But it does a lot of cool and fun stuff as well, such as solving your Sudoku puzzles. So you can just hold your puzzle in front of, for example, your camera, and it solves it for you. Or do some maze puzzles, and it just solves everything for you. But mainly we are here to learn about the image processing, and of course these are examples of how MATLAB can be used in different aspects. But we will move on to like different packages, including SPM for brain imaging as well as we go along. And so, as I said, it has a lot of packages that are built to help you as well. So it has some advantages and disadvantages compared to other programming languages. Like, it's not free, it needs a license, and it's very big on your hard drive and all of that. But it has a vast library of toolboxes, and it's very reliable. And a large number of engineers and scientists in different industries and academia use MATLAB. So it's something that you need to know if you are doing data processing and data analysis. And it mainly helps you analyze your data, develop algorithms and toolboxes of your own, and create models and applications as required for your positions. So I'm going to show you something that I like as one of the fun stuff MATLAB can do. Sorry, my son seems to be joining us now. So I'm sorry about it, but you must be used to this by now. Yes, it's working, but go to your room. Sorry, bear with me 1 second. I'll be back. Sorry about that. So this is a code that someone has designed, and I'll show you what it does. So if you have a cat, so this guy realized that when he's coding and he just leaves the computer to take a break, his cat goes on his computer and basically ruins everything. So he wrote a piece of code that actually just is on the monitor, and the focus and attention of the cat goes on the monitor and nothing else. So I quite like it. You can use it. I will share it with you if you have a cat. I don't. So I will move on. So if you have MATLAB already, you might want to open it and have a look. But this is how basically the interface looks like. So we have different sections, as you can see. We have tabs on top, and the tabs have like normal standard menu tabs that you see in different applications as well. We have on the left-hand side the current folder and descriptions. So that's where your folders are, and the current folder is basically where your files are going to be loaded from and saved to. And basically you can keep your files in that folder, and MATLAB would recognize them and you can use them as required. In the center we have, I have opened the scripts, but you might not see that because you might not have a script open. But you have the command window. That's basically where everything happens in MATLAB. So that's where you write your code and like tell MATLAB what to do. On your right hand side you have workspace. So this is where all the variables and like outputs, if you like, are going to be stored, and you can use these variables for later. You will see this as we move along. And your interface might not, your layouts might not look like this, so you can actually move these around if you want, and you can set them back to the defaults, which is what you see on the screen. But feel free to explore different options if that are available to you through the menus, icons, and by right-clicking your mouse on different things, you learn stuff. So we will go through some of the main things as we move along. So that's MATLAB. Now, there are two ways you can do this. If you have a desktop, you can just open your MATLAB desktop, or you can navigate to this website. It's an online platform, online MATLAB version, which looks very similar to the desktop version. And you just need to sign in to be able to use the platform. So in that email that I sent around, I told you that you need to have a MATLAB like account, and sign in with that account to this website, and we can start coding. So I will open my desktop MATLAB for you so you can see. No, don't save it. Good. So this is basically how your MATLAB should look like. So I can wait for everyone if they haven't opened it yet, or we can start. Is everyone ready? Yep, if you're not ready, just let me know and I will pause. So as you can see, my current folder at the moment is this one here, and you can see the path on top. So this is where I am at the moment. So you can create like a folder here and just work from a specific folder by right-clicking and clicking on new folder, and you can have like a specific folder for MATLAB sessions. Good. And then if I move inside that, this is now my current folder and where everything is going to be. So as I said, everything happens in the command window, and this is where you start coding. So first things first, there is something that engineers love to do when they start programming. So fprintf is something that prints stuff for you in MATLAB. So hello world, and it just writes hello world for you. And as I said, it can be used as a very simple calculator for you. So you can just type random stuff. I'm doing a multiplication, so 23 times 459, or whatever you want to explore. And that's the answer. So as you can see now in my workspace, there is a variable called ans, which stands for answer. And that's the answer. And now it is stored in the variable ans. So let's do different things. Let's now try to do a division. So I'm doing 321.2 divided by 43187. So we have the answer. As you can see, now answer is replaced by the result of the division that we did. Now division is /. If you do /, what would happen? Does anyone know the answer? No? Yes? You can type in the answer, or you just put your microphone on and tell me what you think. It also divides. Yes, that's true. But what is the answer that we see?
Looks like the inverse, and that I didn't know.
That is true. So it divides the other side by this. Am I right? So if I now do 43,187 divided by 321.2, they have the same answer. So it's important to note that, like, how you're doing your division. Let's do something else. So as I said, everything is stored in answer. So if you type answer, which is the variable that is stored in your workspace, it just shows you what is stored inside it. So there is a very important thing here. So you need to actually have different variables, because as you know, in programming, there are like times that you need to use a variable that you have created previously. So for example, let's call this x and do 2 to the power of 3. Good. Now, as you can see, we have x here, and the answer is 8, because 2 to the power of 3 is 8. And then you can use x. So let's say x is y is equal to x minus 4 times 2.1, something random. So now, why, in order to be created, MATLAB has used what we had as x previously. So it was 8. It has used that 8 value in order to complete this command, and has stored the value in y. So it is important to note here what is done first, because we have two different arithmetical things. So one of them is minus, and one of them is subtraction, and one of them is multiplication. So there is an order. So the order is always like the mathematical things that you have learned in high school or university. So here multiplication comes first, and then subtraction is done. So, oh, increase the font. Yes, sorry. How would I do that? Bear with me.
If you go to preferences in the tab,
yes,
home tab,
it's
near add-ons. Yes,
I saw it. Wonderful.
And then choose. I guess it's set around 10 or 11.
Yes, the command window.
It's there is a font.
Fonts, yes, it is now around 13. I was 32, 18. Apply. Oh, is that better?
Yeah, for me, yes. Thanks.
Good, good, good. Okay, so let's keep it on 18. Wonderful. So as I said here, multiplication comes before the subtraction. So if you want to do the subtraction first, what would you do? So here we need to use the parentheses. So I will type it for you so you can see. So if I type z is equal to, this time, x minus 4 inside the parentheses. Now MATLAB knows that this should come before the multiplication. And obviously the result is now different. So it is doing 8 minus 4, which is 4, and then multiplying it by 2.1, and the result is stored in z. There is something about creating these variables. So it is very important that you choose a valid name. So just like so many other programming languages, you can't just randomly choose your variable names. It has to follow a protocol. The protocol is that, for example, if I want to do this, I will get an error. Why? Because in the name of the variable, number cannot be there. So numbers cannot be in the beginning of the name of the variable. They can be, for example, if I type x3 is equal to 3 times x, this is fine. And now there is a variable called x3, but you can't put the number before the letter. And you can't have certain characters on your keyboard in the name. So you can't have @ or $ and stuff in the name of the variable. It follows literally the standard procedure for naming variables for coding. So as you saw, now we have x3, which is 3 times x. What else can we do? So you can call the variables that you have created as well. So if I, for example, have forgotten what x was, you can simply type x. And if it is in the list of your variables in the workplace, it will show the value of that variable. So we have x, we have, for example, y, you can see it. And if I type, for example, a, it doesn't know what a is, so it can't recognize it. And it tells you there's something wrong, we don't have a in the workplace. One more thing is that, for example, if I type y and put semicolon, you're calling y, but semicolon basically surfaces the output. It doesn't let the output to be shown in the command window. It doesn't show you the output, but y is there. And the value hasn't changed, obviously, because I didn't do anything to y. But if I type simply y, it will show you the output. And likewise, if you see on top, I created x3, which is 3 times x. Before, I didn't put the semicolon, and we saw the output. Now, if I put semicolon, it wouldn't show us the output, but it is storing the result in x3. So let's try something else. Let's try, for example, 4 times x and call it x3 still. So here, x3 is now changed to 32 because 4 times 8 is 32, but we are not seeing the output here. So from now on, if I'm using x3, the value is 32. Another built-in function that you can use is who. So who basically shows you what variables you have in your workplace. And it's just the name of them. You don't see the value of them. You can type in whos, and then that will show you different characteristics, properties of those variables. And we will get to these and what they mean as we move along. It's just for you to know what happens. Another built-in function that you can use is called clear. So clear deletes the unwanted variables from your workplace. For example, I don't want to have y in my workplace anymore. So you can type clear and y, and there is no y here anymore. If I want to create y again, I basically have to type y is equal to whatever it was before. But basically y doesn't exist in your workplace anymore. And if you type y, it is not recognized. Clear all, if you want to clear all of your variables, basically you just simply type clear all. And all is one of those keywords that MATLAB knows what you mean by it. So basically you clear all and all your workplace will disappear and it's now cleared. You don't have any more variables stored. So now if you want to load data files, there is another function for that called load. So there are different types of loading, as in importing data. And your data can be in forms of a CSV file, an Excel file, a text file, or a picture, an image, which we are going to do later on. So load is one of those functions that you can use in order to import your data. What else? So load and CLC. So CLC is one of those very useful functions as well. CLC basically clears your command window. So as you can see, I have some errors. I have like a list of different things that I have entered previously, and they are all here. So if I type CLC, basically all of them would disappear. And I have a clear screen from then onwards. As I said, for example, MATLAB has built-in constants as well. So if you just type a is equal to pi, MATLAB knows what pi means as well. And that's your pi now. So a is now assigned as the value of pi. So I will go back to my slides now. So what just happened? I put this with sound for you because you need to hear this. So this was a centrifuge of this tiny creature. So what did we learn? Sorry if I'm going a bit fast, but we have only 2 hours, so I need to cover so many things. So we realized that equal is assignment, so we can just define variables and assign different values to them by equal. If you put semicolon at the end of your command, you're suppressing the output. Oh, we didn't use up and down. I will do that later. But if you use up, you can go back in your commands and just choose from them and use them again if you need to. MATLAB is case sensitive. So if you have a, okay, I need to show you this. Bear with me. So now I have a in my workplace. If I assign a is equal to 5, but capital A, MATLAB is case sensitive, so it knows that you had a small a before, but now you're having the capital A as a different variable. And as I said, if you go up, if you press up on your keyboard, you go through a list of your commands, which is called basically history. And you can choose from them, and basically, if you press enter, you're running that line again, whichever line it is. So here we don't have X. Obviously, we are going to get an And what else? You can use the variables that you have defined in the workspace. The general precedence of these operators, the operators that we mentioned, you can see it on this screen. I'm going to share the slides with you after the session, so don't worry if I'm going a bit fast and you're missing this. And I talked about entering your expression. So it's very important if you want certain commands to be done before other ones, you need to use the parentheses appropriately. It's very, very, very important. And I will talk to you about run as we move along, because we need a script to do that. And you can use a lot of built-in functions, as you realize that MATLAB has for you ready already. So how does it work? So everything in MATLAB is stored in the basically every variable. They're just arrays, and they can be arrays of different values inside them. And they can have different sizes or different dimensions. So the very basic ones that we deal with are these three. So we have scalar arrays. So they are just single values. So for example, if I say 2, that's just a numerical value, and that's a scalar for us. And we have vectors. So we have one dimension. They are one-dimensional arrays. So we have 1 times n, which is basically 1 row of n values, and they are called row vectors. Or we have m times 1, so basically m rows and 1 column, and they are called column vectors. You're going to see a lot of these later on. And we have matrices. So as I said in the beginning of the session, MATLAB is designed to work with matrices. So matrices are basically structures that look like this one at the bottom of the screen. So we have m by n, which is basically m is the number of rows and n is the number of columns. So here we have a 2 by 4 matrix. So we have 2 rows and 4 columns. So the order, as I mentioned, is row and column. And that's what defines the size of your matrix. So it's always the size, the number of rows and the number of columns after that. So let's go to MATLAB again. And let's do some other things. So I will just clear everything and CLC so we don't have anything from before. So let's create a vector called A that has certain values in it. So I'm choosing 11, 15, 3, and 6. So if I press enter now, you will see how A looks like, and you can go double click on A in your workspace, and basically it will show you what A looks like in the form of a matrix. So this is like an infinite number of rows and columns, but A is basically here. So we have 1 row of 4 columns, and each of these columns and row and columns have a value inside it. So it is stored like this, and it is showing it to you in your command window. So what if I want to know, so you have a vector that you have no idea what it is. What if I want to know what the second variable in this second value in this vector is? So this is called indexing, and it's very, very important. So you have your data, you have imported it to your MATLAB, so it is in your workspace like A, and you want to know what the second value is. So in order to index inside A, you use the parentheses, And since we want to know what the second value is, you just put 2 inside. And that will show you that the second value of A is 15. And now it isn't stored in ANS. So let's have another one called B, another vector or matrix. 6, 13, 21. So in order to define your values inside your variables, here I used comma. So as you saw, comma means just move one cell forward, if you imagine the matrix. So it was first 11, then I put comma, it moved one cell forward and stored 15 because it was the second value. So it moved one cell forward 15, one cell forward 3, one cell forward 6. Now you can use comma or just simply press space and it does the same thing. So it just moves one cell in the same row forward. So let's create B as 6, 13, and 21. If you put semicolon here, then it goes to the next row. So now we have 6, 13, 21 in the first row, and I'm going to give it some values for the second row. So 8, 0, and 5. So if I press enter now, it shows us that B looks like this. So we have, as I mentioned, 6, 13, and 21, which is here in our first row. Then I enter the semicolon, and now we have moved to 8, 0, and 5 in our second row. So now we have the matrix B, which is a 2 by 3 matrix. So 2 because it's 2 rows, and 3 because it has 3 columns. So it is a 2 by 3 matrix. And let's now index into B. So if we want to know the fourth value of B, we just type it like this. Just like I did the second value of A, I extracted the second value of A and it was stored in the ANS variable. So we are now trying to extract the fourth value in B. Now let's see what it is. Oops, that was A. And now the fourth value of B is 0. So how does it count? Why didn't it go 1, 2, 3, and 4 is 8? No, that's not the way MATLAB counts the values inside the matrix. So the way it counts is that 6, 8, 13, 0. So it is counting on columns to go through the values inside that matrix to extract the value that you wanted, you asked for. Now, if we want to know another like value inside this 2 by 3 matrix, if we want to know, for example, what is in the first row and the second column, that's the way we do it. So we are trying to extract the value that is in the first row, so that's where we put the first number, comma, second column. And now we are indexing into that matrix to extract that value. So as I said, first row, this is the first row, second column. So that's the value that we are looking for, 13. And that now has been stored in our answer. What if you want to extract multiple values of this matrix? So imagine we want more than just one value. We want to extract multiple values. In order to do that, you need to know another thing. So for example, we are trying to get A was a 1 by 4 vector, 1 by 4 matrix. So if we want to get the first 3 values out of A, this is the way we do it. So we say 1, 2, 3. So basically, this is the first element up to the third element and including that. So the answer of this is now 11, 15, and 3. So if you remember, A was 11, 15, 3, and 6. So we are now extracting the first three elements by this command. So we are saying A, 1, 2, 3. If we want to, let's do another one on B. So for example, we are B is a 2 by 3 matrix. Imagine we want to extract the first row, and from that row we want to extract, for example, the second and third column. So let's see how that works. So we are going inside the first row and we are extracting columns 2 to 3. So this was B. We are in the first row and we are going to extract elements 2 to 3. Another way of doing that is, because 3 is our last column, you can simply say in the first row, extract the second element to the end, and end is 3 for us because it only has 3 columns here. So if I press enter, I will get the same output. What if I want to extract a whole column in that matrix B? So for example, we want to extract the whole of the first column, so all the elements of the first column. This time we put this sign instead of the rows. So we want all the rows of the first column. This sign means like every single element, and this is for the column, stands for the column. So if you look at B, we basically try to extract all the elements in the first column by just entering this command. So you can now basically create different size, different dimension matrices and index into them and extract multiple values. So let's move back to the slides and see what we learned. So this is indexing. So it's a very important thing in like analyzing your data, because you need to know like different elements in your data matrix sometimes, and that's why indexing and extracting elements is very important. So here is what we had. So we had a vector called A, and that's how it looked like. And we had like the matrices, which was in our case B, and these are the values that we input in our commands and created B. And this is like an example of indexing, which we already have done. And you can think of it like the battleship game, that you have to think about where the ships are on the matrix of your data, basically, and try to locate them and extract them. And as you can see at the bottom right of the screen, this is how we index into a matrix or vector. So the first element is indexing into the rows, and the second element defines the column that you are looking for. And that's about it. So let's go back to MATLAB again. Is everyone okay? Or are you already tired? I assume everyone is fine. Okay. So I will do another CLC. Hope we had a few questions. Thank you, Martina, for looking after these. Yes, okay, clear. Good. So let's try creating a vector called x, which is 1, 2, 6. So as I said, these columns mean 2. So we are creating now a vector called x, which has the values of 1, 2, 6, and including 6. So that's now like the vector that we have. And y is, so if we wanted to, this is stepping one at a time. So it's going 1, 2, 3, 4, 5, 6. If we enter our step, then we will have that like the range that we have specified from 1 to 6, and we are trying to divide that into different sections rather than just one by one. So this is the way we do it. So I'm saying step every 0.5 and go from 1 to 6. And now we are creating y, and this is the way it does it. So MATLAB is telling us we have started from 1 as the first element, and we are stepping 0.5 at a time. And we go until we get to 6, and including 6, because that was the end of our range. So this is very useful as well when you want to have like a range of numbers, and you want to have like certain number of elements inside that range in order to create your variable. Another function is this one. So this is called transpose. I'm adding just a like single apostrophe after x. So let's see what happens. So x was a vector, single row vector of 1, 2, 3, 4, 5, 6 columns. Now z is a transpose of x. So that's what it is called. This is the way z looks like. So z is 6 rows of one column, and every element is equal to the elements of our x. So x looks like this. So it was one row of 6 different elements in different columns. Z is one column of six different rows, and the elements are the same, the values are the same. So this is called transpose. And you might need to use it when you are doing certain things like multiplication in matrices. We will get to that and you will see what I mean. Okay, MATLAB has some built-in functions, as I mentioned, that are very useful. We already have used several ones of them, like clear, like CLC. One of them is rand. So let's define x as rand of size 4. Let's see what happens. So rand creates a random matrix of that size in both the number of rows and the number of columns. As you can see, these are values between 0 to 1. So rand has now created a 4x4 matrix for us that has random values inside it. We didn't define these were randomly chosen. And each one of them is from 0 to 1. And they are just randomly assigned to different positions in our matrix X. So if you want to have a certain size random matrix, you can define what sizes that you have in mind. So for example, Y is now going to be a 2x4 matrix because we defined that we want 2 rows and 4 columns. So as you can see, again, the values are randomly assigned to Y and to each cell in Y. sorry, wrong one. And they are all between 0 and 1, but we specified the size that we desired. So it is a 2 by 4 matrix now. Then another one is zeros. So for example, you want a random matrix of size 5 and 4 that has zeros in all the elements. So you can use the built-in defined function of zeros. So this is now creating a 5-row by 4-column matrix of just zeros. There is nothing else in these but zeros. So this is not just random numbers assigned to the elements, it's all zeros. Alternatively, another one is ones. So if you want to create a matrix of random size 4 by 6, they're all going to be ones. So this is not random, you're specifying what you want those values to be. You're saying it's either 0 or it's either or 1. Okay, let's clear our screen and our workspace. So I press clear, or I can do clear all. They both do the same thing. And I do CLC, so I don't have anything on my screen. I want to start scratch. So we want to create a data variable randomly of size 7 and 6. So 7 rows, 6 columns of random variable values between 0 and 1. So imagine you have this data. And now let's try to index and extract certain numbers in this. So how do we extract the value of row 3 and column 5, for example? Let's practice that together. I'll give you a few minutes. So we are trying to extract the value of row 3 and column 5, and we can store it in a variable of x, for example. So what are we trying to do? Extract element of row 3 and column 5 and store it in X. So as you can see, this time that I type things, it's not in a command mode, so this is something else. MATLAB uses %sign in order to create comments. So this is just a comment. MATLAB knows it shouldn't do anything. It's just for the user's information. It doesn't do anything. It's just a written text for the user, whoever uses this piece of code. If I press enter, nothing happens, nothing is stored, and nothing is reported back. So we're just simply writing this exercise. So I imagine everyone has already done it. So we are trying to index into data. Since it is row 3, we put 3 first, then comma, and column 5. And that's the value that we are looking for. So let's see, row 3 and column 5, 1, 2, 3, 4, 5, and this is the value. Nope. This is the value that we extracted. Now, let's try something else. So if you remember, we talked about end. So end is normally the last value. So it is either the last row or the last column, wherever we put it. So I will write another sort of exercise thing. Element of row, last row, let's do row, and column pull, and store it in Y. So this is our exercise. let's try to do that. So extract the element of last row and column 4 in data and store it in y, a variable called y. So we know we have to extract that element from data, so we type data. The last row is going to be end, and the column, we set the 4th column, so it's going to be 4. Ooh, that's a good question. So I noticed that I got exactly the same matrix of random numbers. Does it mean that it is not completely random? That is true in a way. So it is random, but there is a protocol for random as well. So there is something behind that random function that MATLAB uses. There is a way of choosing those values that might be very specific. So if I press enter now, y is extracted. So it was the last row and the 4th column. So the last row is here, and the 4th column is 1, 2, 3, and 4. So this is the value that we are looking for, and it is stored in y. Good. Alternatively, you can use different combinations of and. So for example, instead of saying x is equal to data 3 and 5, which is what we had before, so here we did that, we know that our matrix is a 7 by 6 size, so it has 7 rows and 6 columns. So we know that 5 is like 1 to the end, so 5th row is this one here. So instead of 5, since 6 is our last column, I can use end minus 1. So I will get the same value. So there are combinations of end that you can use to get like the value that you desire. If you had like a very, very large size matrix, end is normally quite useful to go to the very last if you don't know what is the last number. Or you have multiple matrices and you're trying to extract the last value of all of them, then you just use end, and it doesn't matter what size they are made of. You are extracting the last column or last row of those matrices. Good. Let's try to extract more than one value. So I will just type it here, extract the 2nd row of data and store it in Z. So let's do that. So we know that we have to extract into data, so I will just type that. And then we fill that in whenever everyone is ready. So we are trying to extract the 2nd row of data. So all the elements, all the values that are stored in the 2nd row. So it is going to be the 2nd row, so 2. And since we want all the columns, so all the variables in all those columns, I will just put the columns sign, and I have all of those values. So how is this stored? So we said we wanted the 2nd row and all of these variables. Now, MATLAB has created a row vector of these elements in data, and has stored it in Z. So if you look at Z, it is literally identical to the second row of data. So this is it, and all the values are stored in Z now. So we extracted all of those values and saved it in, stored it in Z. Good. Now let's create a new variable, call it R, and extract all the rows in the last two columns. Store it in R. So we are trying to extract all the rows in the last two columns and store it in R. And imagine that we don't know what the size of data is. I know that we know it's a 7 by 6 matrix, which is mentioned here. But try to use AND for this, basically. Good, so all the rows, so instead of rows, I put the columns, and instead of the last two columns, I can just say n minus 1, because that's the one to the last, and end. And now I have the last two columns, because it is in the position that we specify what columns we are looking for, or what column we are looking for. Here we have more than two columns. So R is now formed from basically these two columns. So all the rows of these last two columns are stored in R. And if we look at it, it is now a 7 by 2 matrix. So it has 7 rows and 2 columns. And the values are extracted from the last 2 columns of data. So they are identical. Now, what if I want to change one of these values? So there are so many times that you have missing data. So one of these cells that you have imported your data is missing or is empty, or it has a variable that it has a value that you need to change it. What if we want to change that? So, for example, we want to change the value of the 4th row and the last column. So which one is it going to be? So 1, 2, 3, 4th row and the last column, this is the value, and we want to change that. So imagine we want to change that. So let's see what it is first. If I press enter now, this is extracting that value. Now I'm pressing up, so I have that typed in again, that line, because this was my last line. If you assign a new value to it, so for example, I will assign 789 to it, then you can see the 4th row and the last column, that element has changed to 0.789. And if I run it again, run that line that we wanted to extract that value again, we see that that is that. So we have changed one value inside our matrix data. So this is how you replace values with new values of your choice. So what else do I have to say on this one? Yep, let's move back to the slides. So we realized that everything happens between these square brackets. So if you want to create a vector or create a matrix, you need to basically put those values inside these brackets. If you know what the values are, if you don't know, as you realize, we used different functions like rand, like ones, like zeros, and you can just create matrices and vectors of different values. But if you know the values, this is the way to create your vectors or matrices. As I mentioned, the comma is, or space, is to separate the elements in the same row. So you remember we put commas or spaces and we were just moving one cell forward in the same row. And if you put the semicolon, you start a new row, you go one row down and you basically put your elements in those as you're creating your matrix. And indexing and extracting values is very useful, and now you know how to do it. It's extremely useful to know like what to do with your data, because this is basically the first step in your data processing. Then after you have imported your data, you need to know what is inside it. So indexing and extracting the values is extremely important. Do you want a 5-10 minutes break? This is a good time to stop, and we can have a break if everyone is happy. If you have any questions, please turn your microphone on and ask, or just type in. And I'm going to start at 25 past, if that is okay. 10 minutes. Everyone is exhausted. Yeah, 10 minutes break, that's good. That's a very good question. So I will put my screen on again if I manage to. So let's try to do that. Good. So let's create a new variable, call it D. And we are trying to extract the data from, for example, first and third column of row 4. So the first column of row 4 is basically this one. And the third column of row 4 is this one. So you're trying to extract these two variables, the values. So basically you have two values. The way you define your matrix is, as I mentioned, the brackets, the square brackets. So we have two values. I would delete my semicolon so we see them. So just like the way with indexed into data. So what was the number of rows? 4 and 1. So this is our first value. So you are saying row 4, first column, and space if you want it to be in the same row. And then you do row 4 and third column. Now you have those two values extracted and stored in a new variable called d. This is because you don't want, for example, go from first column to the third column. If you wanted that, you had to do 1, 2, 3. So this would, if I call it something else, d1, this would give you three variables, three values on 4. So these are the first 3. But then if you wanted just this one and this one, this is the way to do it. So I will copy that to the chat. Thanks, Peter. Yes, thanks, Martina. These all are alternative solutions. Yeah. Okay. Don't know if everyone is back or not, but I'm going to share my screen again and be continuing. Okay, let's go back to MATLAB and we start doing some more fun stuff. So as I mentioned, everything is in MATLAB in the form of matrices. So there is one video that I am going to try to share with you, and that explains multiplication in MATLAB in matrices. So this is from Khan Academy. If I manage to move it forward, yes, okay. And play this.
We're given two matrices over here, matrix E and matrix B, and they ask us what is ED, which is another way of saying what is the product of matrix E and matrix B. So I remember what I'm doing. Copy and paste this, and then I'm going to get out my scratch pad. Here, all the information we needed. So let's try to work this out. So matrix E times matrix E. So this is matrix E times matrix B. Matrix E is all of this business. So it is 0, 3, 5, 5, 5, 2 times matrix B, which is all of this. So we multiply it times 3, 3, 4, 4, negative 2, negative 2. Now, the first thing that we have to check is whether this is even a valid operation. Now, the matrix multiplication is a human-defined operation, but this happens, in fact, all operations are, that happen to have these properties. Now, the way that us humans have defined matrix multiplication, it only works if, when we're multiplying our two matrices, so this right over here has 2 rows and 3 columns. It's a 2 by 3 matrix. And this has 3 rows and 2 columns, 3 by 2. This only works, we can only multiply this matrix times this matrix if the number of columns on this matrix is equal to the number of rows on this matrix. And in this situation it is, so I can actually multiply them. If these two numbers weren't equal, if the number of columns here were not equal to the number of rows here, then this would not be a valid operation, at least the way that we have defined matrix multiplication. The other thing you always have to remember is that E times B is not always the same thing as B times E. Order matters when you're multiplying matrices. It doesn't matter if you're multiplying regular numbers, but it matters for matrices. So let's actually work this out. So what we're going to get is actually going to be a 2 by 2 matrix. So I'm going to create some space here for the computation. So this is going to be equal to, I'll use a huge 2 by 2 matrix here. So the way we get the top left entry is essentially going to be this row, times this product. We view them each as vectors, and we have something here with a dot product. We're essentially going to take the dot product of that and that. If you have no idea what that is, I'm about to show you. This entry is going to be 0 times 3, 0 times 3, plus 3 times 3, plus 3 times 3, plus 5 times 4, plus 5. So that is the top left entry. You see that I'm going to run out of space. Right. Breathing room. Now we can do the top right entry. This is the top left. Now we're going to do the top right. So the top right entry is going to be this row times this column. This row times this column. Notice the entry is getting the row from the first matrix and the column from the second one. That's kind of determining its position. So once again, it's going to be 0 times 4, 0 times 4, plus 3 times negative 2, 3 times negative 2 plus 5 times negative 2, 5 times 2, and we keep going. The bottom left entry is going to be this row, the second row here, times the first column here. So it's 5 times 3, 5 times 3, plus 5 times 3, 5 times 3, plus 2 times 4, plus 2 times 4, and we're almost done. We just need to multiply, take the dot product of this row with this column. Right? 5 times 4, 5 times 4, plus 5 times negative 2, plus 2 times negative 2, 2 times negative 2. And so this is going to be equal to, and we can just put the value of this now. 0 times 3 is 0. This is 9 plus 20. This is 29. This all simplified to 29. All of this is 0. This is negative 6. And then this is minus 10. So this all simplifies to negative 16. Negative 16. This right over here, it's 15 plus 15, which is 30, plus 8. This is 38. 38. And then finally, this is 20, 20 minus 10 minus 4. So this is going to be 6. So this is all going to simplify to 6. So this all became 29, negative 16, 38, and 6. 29, negative 16, 38, and 6. 29, 29, negative 16, 38, and 6. You got it right.
Good. I will share the link of this in our chat. So this was a matrix by matrix multiplication. And we are going to need that and get to it. So let's clear our workspace of all these variables and clear our command window. So let's start fresh. Let's create a variable called x, which is 3, 6, and minus 4. So this is a row vector 1 by 3, and it has the values of 3, 6, and minus 4. Now let's create a new variable called y, which is equal to x plus 3. So what we are doing is that we are choosing the variable that has been previously defined as x, and we are adding a scalar to it, which is just 3, a number to it. Let's see what happens. Oh, and y. So basically, what it is doing is that it is adding that number, which was 3, to every single element of x. So x was this, and if we add 3 to each element, so 3 plus 3 is 6, 3 plus 6 is 9, and 3 plus minus 4 is minus 1. So this is just a very simple addition of a scalar and a vector, and that's how it is going to be done. Now let's create another variable called z, which is the sum of x and y. So let's see what happens now. As you can see, y is a 3 by 1, a 1 by 3 vector, and x is a 1 by 3 vector as well. So we are adding these two together, and what happens is this. So basically, each element of x is now added to the equivalent element in terms of the position of that element in y, and the result is in the same position in z. So basically, x and y, it's good that they are under each other. You can see 3 plus 6 is 9, 6 plus 9 is 15, minus 4 minus 1 is minus 5. So this is the addition of two matrices. It is very important to note that matrices, they have like a huge amount of information in terms of what happens mathematically when we add and subtract and multiply them together. So I'm just showing you the very basic addition, and we just saw a video on multiplication. And there's a lot more to it, but I'm going to use examples as we move along, and we can just understand the basics of that. So let's create a new variable called Z1 and do a division this time. So let's do Z divided by 2. So as you can see, this is a forward arrow, so it is going to take Z and divide it by 2. The result is this. So as you were expecting, just like adding a single number to the value of values of x, this is just dividing each element of Z by that number that we have specified. So it is saying 9 divided by 2 is 4.5, 15 divided by 2 is 7.5, and minus 5 divided by 2 is minus 2.5. And it is stored in our workspace as a new variable. So another built-in function is called min. So as you might guess, sorry, we have a Z1, let's call this Z2. Min basically outputs the minimum value in all the values of Z1. So Z2 is now the minimum value out of all the 3 values that were stored in Z1, and the minimum is minus 2.5. So this is a very useful built-in function, minimum, and likewise we have max, M-A-X, which basically shows you the maximum of the variable of your choice. So we are trying to find the maximum of Z1 and store it in a variable called Z3. So obviously the maximum of these 3 variables is 7.5. So this variable is extracted and is stored in Z3. Now, if we want to find out what max actually does, so this is one output. So we have specified that we just want one output, but there is another way of doing that. So if we say Z3 and IZ3, I will explain what these are, and use the same command that we entered the line before. So this time, instead of saying Z3 is equal to max of Z1, maximum of Z1, we are specifying 2 variables. So this is already a vector. And we are saying put the output of this function, max, in these 2 variables. So what happens is that it is telling us that the value of the maximum is 7.5. It is stored in Z3. The next output is IZ3, which is the index of the maximum value, which is the position in position of the maximum in Z1. So basically, if we look at these 3 values, we know that the maximum is 7.5. So this is the maximum value. But where is it positioned is by the second output. So it is defined in our second output. So max, in theory, can have 1 output or 2 outputs if you like to know where that maximum number is stored in Z1. So that's your index. Again, this is very, very important in the concept of indexing and extracting values in your data. So let's create another variable called Z4 and try to find out what round does. So round is basically, as the name says, rounding our value to the next scalar value. So whether it is less than 0 or more than 0. So our Z2 variable had the value of minus 2.5. So you can look at it here in our command history, or look at it here in our workspace. So the value was minus 2.5. Now, if we round it, it is going to be minus 3, because if you round a negative value, it's going to be just the next scalar is minus 3. So let's round another value, which this time can be positive. Let's round Z3. So Z3 was 7.5, so it was floating number, and the round one is 8, so it is rounding up the value of Z3, which was 7.5, rounding up, it's going to be 8, and storing it in Z5. So these are, again, useful built-in functions that you can use. If you want to get more information about these built-in functions, so there are two things you can do. If I, for example, type doc and the name of the function, I'm going to get a new window that is a help window, and it navigates to the MATLAB documentation for that specific function. So here we did doc space round, so it is going to show us all the information that we need in terms of how the syntax is written, how many inputs you can enter, and how many outputs you should be expecting. A description of the function, what it actually does. So it is basically rounding each element of the input, which is here x, to the nearest integer. And also you see examples. So if you navigate down on that page, you see examples. So we have x defined here and round of x. So you can see it's a 2 by 2 matrix. So round of x is going to be a 2 by 2 matrix, which is now stored in y. And each of these values is rounded to the nearest integer. So as you can see, 2.11 is rounded to 2. 3.5 is rounded up to 4. Minus 3.5 is rounded up or down in minus 4 in terms of the way you look at it. And 0.78 is rounded up to 1. So this is the nearest integer to each of those values, and the output is y. And if you go down, you can choose the format of your output. So this is something that some people might be interested in. So these are the formats of how MATLAB shows the values of your outputs. You can look into that by just choosing, like typing doc format, and it will show you everything, or help format. And basically you can just go down and see what different options you have in terms of finding what round does. And you can also look at similar functions, which are, for example, here suggested to you. So seal, fix, and floor, and each of them does a different thing, just rounding to the highest number, rounding to a lower number, or different things. And also, if you type help, you can see things in a different way. So it gives you a summary of that page in terms of just text on your command window. So this is quick. So if you don't want to go to the page, to the online page, you can just look at this. And it has basically everything that the online page has. It's just the text format of that, and including the examples and everything that we just talked about. So now let's do something else. So for example, all of these functions that we just used, all these built-in functions, if you want to get more information about them, you can simply type doc space and those. And for those that there was a sign for them, like times, multiplication, you can find out what that function is called in terms of the full length name of the function, and just type doc times. M times is basically the multiplication, And the multiplication can be written in two different ways. You can use the sign or just use the function m times, which is something that I typed here. And again, you have all the information you need about multiplication on this page. There is an option of opening live script in the platform, and basically it opens a simulation of MATLAB, and you can just use it to type in different commands and see the outputs. That's another useful command. Now let's do the multiplication that we were talking about. So we talked about multiplying two different matrices. So one thing about the matrices that you saw in the video is that something about the size matters. So I will tell you what. So if I try x multiplied by y and put it in something called a variable called z6, what happens? So if you can see, we get an error here. Why is that error happening? So if you look at the size of x, x is a 1/3 vector. So if I type what x is, 3 for x. And for y, we have again a 1/3 for y. Okay, so when you are doing the matrix multiplication, if you wanted to work like the way that the matrix multiplication should work, as you saw in the video, these two numbers, so the number of columns of the first element of the multiplication should be equal to the number of rows of the second element of your multiplication. So that's why we are getting this error, because we can't multiply a 1/3 by a 1/3 matrix because 3 is not equal to 1. So now how would I do this? So if I create another variable called y1 and simply transpose that, now I can do x times y1. Why can we do that? Because now y1 has a size of 3/1. So x was of size 1/3 and y1 is of size 3/1. So if you can see, the number of columns in x is equal to the number of rows in y1. That's why we can do the multiplication. The output is always going to be of size number of rows first element times number of columns second element. So here our output is just a number, is a 1/1 number. So this is the way it works. There is another way of multiplying x and y, so let's try that. So z7 is x, y. So does anyone know what this one does? What is happening here? No? So basically, this multiplication is doing an element by element multiplication of each element in x with the equivalent element in y and storing it in the equivalent position in z7. So x, the first element is 3, y, the first element is 6. So 3/6 is 18. The second element, 6 times 9 is 54. And the third element, -4 times -1 is 4. So this is another way of multiplying. The difference is this dot. Dot means you're doing an element by element multiplication rather than multiplying two matrices by each other. So that's another arithmetic thing that you can do. Another built-in function that is quite useful is size. So let's try to find out the size of Z1. So what size does is that it goes and finds out what is the size of Z1, literally. So it is a 1 row by 3 column matrix, and it is showing you that it has 1 rows and 3 columns. So size is again quite useful when you have a large data set and you don't know how many elements are stored in it, how many rows it has, how many columns it has. And I can simply type this because now it is stored. If I want to see the output, it is stored. And there is another way of displaying it as well, which is this. So you use the function disp for display, and it should show you the size of SZ1. You can also make it a bit prettier by adding a text to it. Size of SZ1 is, and then I can do this. So basically it types what I wrote as a text. So display does that. It just displays stuff for you. So I wrote a text thing here, and then I wrote display SZ1. So the output is now displayed as a text for you. And the result of my command. Back to our slides. So very subtly, you now know how a function looks like. So a function is a set of sequential commands performed on the inputs to return certain outputs. So this is the way it looks like. So we have certain number of outputs in square brackets, then the name of the function, and then parentheses, the number of inputs. It can be infinite or as many as you define the function to have. For example, we looked at the function maximum, and we had 2 outputs. So maximum can output the value of the maximum in Z2 and also identify the index of where that maximum value is located in Z2. So as I mentioned previously, built-in functions are sometimes all that you need. It is done before. You don't need to write your own function, which is something most scientists do sometimes, doing something that has been done before for you. Don't do that. Don't waste your time. But you can, of course, create your own functions just like this, following this format as required by your work. I have 5 minutes left. I don't know how many people are awake, how many people are sleeping. If you want to go do further programming and further coding, there are 2 options that you can explore. So most of you have the MATLAB license. There are 2 websites that, one website that is very useful. So it is called, MATLAB Academy. Most of you are quite familiar with this. So as you can see, if you navigate to matlabacademy.mathworks.com, MATLAB, and you have to be signed in, MATLAB has a range of online courses for you to explore. So far, I can say that you have completed, as you can see, 52% of the on-ramp MATLAB, which is the basics of programming in MATLAB. But there is a large number of different courses that you can explore, including machine learning and image processing, as you can see, signal processing. And MATLAB Fundamentals is very useful as well. MATLAB Fundamentals is a bit more complicated than on-ramp, so I will suggest that you start with on-ramp and then explore fundamentals if you are interested. But we are going to cover what is happening in fundamentals as well. So that's it for the first session. Any questions? Oh yes, thank you, Martina. On-ramp courses are free to anyone, even if you don't have a license. The core ones are not. So you can see all these on-ramp ones you can finish. And the suggested time for MATLAB on-ramp is 2 hours minimum, I think, or maximum. But you can just do it to your own pace, and you can pause wherever you want and go back to it. It just pauses and keeps everything that you have done on your account. For these, you need a license, I imagine. And you can get certificates, which is good. So for this first session, we don't have any exercises really, but you can go practice on ramp, and from second session onwards, we will continue on visualization and other MATLAB tools, and I will have homework for you as well, so you can practice at home. And I'm trying to put together a platform that we can share stuff together and ask questions from each other, so sort of a peer help first before you get to Googling stuff or emailing people. So I'm working on it. There is unfortunately no option for that on Synapse webpage, but I will find a way. So we are going to have a platform for sharing stuff with each other and learning from each other as well. Any questions, any comments? Thank you. Thanks everyone for coming. Thank you for programming 2 hours with us. As I mentioned, I myself, if I wanted to do the survey, I don't consider myself an expert. I'm here to learn from you as well, so let me know if you know anything that is interesting, and I'm very grateful. We have people more senior from me, so I'm expecting to learn a lot from you as well. Thank you. So I will, yes, I will share the recording on our Teams page. Now that you have joined, you'll have access to the Teams page. The recording is going to be there. I will add the slides, and also I will create a script of all the coding we did together and share it with you as an M file. And an important thing is that before each session, I will try to email you what we are going to be going through in the following session. So as I mentioned, if you feel like you know those things, you don't have to join us. It's not compulsory. And you can choose the sessions that are most relevant to you and join us. There is a skills card page for networking. Please complete that. It's in the email that I sent you. If you like, complete the survey as well, so we get to know each other better. And thank you very much for joining. I hope you enjoyed the session, and see you in 2 weeks' time. Thank you. Bye.